video, we will cover all types of motion numericals, class 9th. Formulae to be used in these numericals are: first, v is equal to u plus at. Second, h is equal to ut plus half at square. Third, v square is equal to u square plus 2as. Now here, u is initial velocity, v is final velocity, t is time, a is acceleration, and s is distance. Fourth, the conversion factor from kilometer per hour to meter per second is 5 by 18. Fifth, speed is equal to distance upon time. Sixth, force is equal to mass into acceleration. Note it down in your notebooks before starting with the numericals. Here is our first question. A train starts from rest and accelerates uniformly at the rate of 5 meter per second square. Calculate the velocity of the train in 5 seconds. Now, as the train starts from rest, u is 0, t is 5 seconds, a is 5 meter per second square. Using the first formula of motion, that is v is equal to u plus at, substituting all the given values in the formula, we get v as 25 meter per second. Our second question, a train accelerates from 36 km per hour to 54 km per hour in 10 seconds. Calculate acceleration and the distance traveled by the car. Now here, as the time is in second, we will first convert the velocities in meter per second. Therefore, our initial velocity, which is 36 km per hour, will be 10 meter per second, and the final velocity, which is 54 km per hour, will be 15 meter per second. Time is 10 seconds. Now to calculate the acceleration, we will be using the first formula of motion, that is v is equal to u plus at. Substituting all the given values in the equation, we get acceleration as 0.5 meter per second square. Now to calculate the distance traveled by car, we will be using second formula of motion, which is s is equal to ut plus half at square. Substituting all the values in the equation, we get s as 125 meter. Our third question, Anand leaves his house at 8:30 a.m. for his school. The school is 2 km away and classes start at 9 a.m. If he walks at a speed of 3 km per hour for the first kilometer, at what speed should he walk the second kilometer to reach just in time? So here we have to first calculate the time taken to cover the first kilometer. So let's calculate that. For first kilometer, speed is 3 km per hour, distance is 1 km. So using the formula of speed, that is distance upon time, we get time as 1 by 3 hour, which is 20 minutes. Now the total time he took to cover the distance from his house to the school is 8:30 a.m. to 9 a.m., which is 30 minutes. For the first kilometer, he took 20 minutes. Therefore, for second kilometer, time is 10 minutes, which is 1 by 6 hour. Distance is 1 kilometer. Now to calculate speed using the formula distance upon time, we get speed as 6 km per hour. Therefore, he should walk the second kilometer with a speed of 6 km per hour to reach school just in time. Fourth question. A bullet hits a sandbox with a velocity of 20 meter per second and penetrates it up to a distance of 6 centimeter. Find the deceleration of the bullet in the sandbox. Here, the initial velocity is 20 meter per second and final velocity is 0 meter per second, as the bullet stopped after penetrating for a distance of 6 centimeter. Distance is 6 centimeter. Using the third formula of motion, that is v square is equal to u square plus 2as, substituting all the given values, we get acceleration as minus 3333.33 meter per second square. Negative sign indicates that it is a deceleration, that is reduction in velocity. Fifth question. A stone is thrown in a vertically upward direction with a velocity of 5 meter per second. If the acceleration of the stone during its motion is 10 meter per second square in the downward direction, what will be the height attained by the stone and how much time will it take to reach there? Now here you need to understand a very important thing. That is, when we throw any object in upward direction with a certain initial velocity, its velocity continuously decreases because of the negative acceleration acting on it, and after reaching a maximum height where the velocity becomes zero, it falls back due to gravity. So here, initial velocity is 5 meter per second, final velocity is 0, and acceleration is minus 10 meter per second square. Now to calculate the height attained by the stone, we will be using third equation of motion, that is v square is equal to u square plus 2as. Substituting all the given values and calculating it, we get the height as 1.25 meter. Now to calculate the time taken, we will be using first equation of motion, that is v is equal to u plus at. Substituting all the given values, we get time as 0.5 seconds. Now our sixth question is a graph. Here the velocity time graph shows the motion of a cyclist. We have to find velocity, acceleration and the distance covered by the cyclist in 15 seconds. By reading the graph, we can say velocity is 20 meter per second. Now we can see from the graph that the velocity remains constant, that is it is not changing. So acceleration is equal to 0. Now to calculate the distance, you should know that the distance traveled by an object can be calculated from the area under a velocity time graph. So here, area of this rectangle is length into breadth, which is velocity into time, that is 20 into 15 is 300 meter. Therefore, the distance covered by the cyclist in 15 seconds is 300 meter. Now, our seventh question is again a graph question. Here, the velocity time graph of SUV is given. The mass of SUV is 1000 kg. Now, first, what is the distance traveled by the SUV in first 2 seconds? And second, what is the braking force at the end of 5 seconds to bring the SUV to a stop within 1 second? Now here we know that the distance traveled by the SUV in first 2 seconds will be area of triangle ABE, which is half into base into height, that is half into 2 into 15, which is 15 meter. Now to calculate force, we need acceleration. Now again a very important thing, that is the slope of a velocity time graph represent the acceleration of the object. Now here, as we have to calculate the braking force at the end of 5 seconds to bring the SUV to a stop within 1 second, we will be calculating slope of line CD to get the acceleration. So here slope of line CD, that is acceleration is final velocity minus initial velocity upon T2 minus T1, that is 0 minus 15 divided by 6 minus 5, which will give us acceleration as minus 15 meter per second square. Now to calculate force, we know force is equal to mass into acceleration. Mass is given as 1000 kg. Therefore, 1000 into minus 15 will give us force as 15,000 Newton.